So we're given 5 numbers and we have to find all the prime numbers. So this is really 5 little problems. Is 21 a prime? Is 37 a prime? And so on. So we're going to look at them one by one. Recall that a prime number is one with exactly 2 divisors, 1 and the number itself. 21 is not divisible by 2 because of the last digit is not even, but it's divisible by 3 because it's 3 times 7, right? So 21 is 3 times 7. Now let's move on to 37. We're going to start listing the factors of 37, and if we just find one other divisor besides these 2, we can stop and say this is not a prime. And if we complete the list and end up with just these 2 numbers, that makes the number prime. So we roll up from 1 to 2. 37 is not divisible by 2 because its last digit isn't. Roll up to 3, add the digits, 10. 10 is not divisible by 3, so neither is 37. 4 is not going to be a divisor if 2 wasn't. 5, the last digit is not 0 or 5, so that's out. 6 is not possible because if a number is divisible by 6, then it's divisible by 2, and that's not possible. So we roll up to 7. 7 is not a divisor because 7 times 5 is 35. Or alternatively, if we use the calculator and 37 divided by 7, we do not get a whole number. That means that 7 is out. Actually, we're done. This number is a prime number. Now, why can we stop at 7? If there are no divisors until 7, imagine that we find one. Well, they come in pairs, right? So then we have 2 numbers that multiply to 37, and both of them are bigger than 7. But if 2 numbers are bigger than 7, their product is going to be bigger than 49. So we cannot find a pair after 7, which means that 37 is a prime number. So we found 37 to be a prime. Let's move on to the next number, 77. Sometimes it's just obvious. You probably already see the divisors. 77 is not divisible by 2 because of the last digit isn't. It's not divisible by 3 because if we add the digits, we get 14, which is not divisible by 3. We don't have to check for 4 because we checked for 2. So we roll up to 5. The last digit is not 0 or 5. So 5 is out. And then we roll up to 6, which we don't have to check because if a number is divisible by 6, we would have picked it up right here at 2. And then we roll up to 7, and we find that 7 is a divisor because 7 times 11 is 77. Let's skip 89, and let's move on to 93, which is very easy. Every single digit on its own is divisible by 3. So clearly when we add those numbers, it's going to be divisible by 3. So 93 is not a prime number because it's 3 times 31. So 89 is the only number left that we have to determine. So we find 1 and 89. And now let's be smart. Suppose this number is a prime. When can we stop checking numbers? Well, 89, let's place it between 2 consecutive square numbers. It's definitely bigger than 81, but it's less than 100. So that means that we don't have to check a whole lot. It's just until 10. Because if we don't find a divisor until 10, then we would find a pair where both numbers within the pair are greater than 10, but that's impossible because the product of those 2 numbers would be more than 100. So we just have to check until 10, or if we want to be careful, 11. This number is not divisible by 2 because of the last digit isn't. Add the digits of the number, 17. That's not divisible by 3, so neither is the number. We don't have to check for 4 because if the number was divisible by 4, we would have noticed that it's also divisible by 2. We roll up to 5. No go because the last digit is not 0 or 5. We roll up to 6, which can be quickly ruled out. Now 7. Let's just divide. So 89 divided by 7 is not a whole number, which means that 7 is not the divisor. 8 isn't a divisor because 2 wasn't. We roll up to 9. We can divide or observe that, well, you can't have a number that's divisible by 9 but not 3. So 9 is ruled out, but we can also just divide 89 divided by 9. Finally, also, the divisibility rule for 9 is the same as for 3. If we add the digits as 17, 17 is not divisible by 9. And finally 10, which is an even number, so we don't have to worry about it. So now if we find a pair of divisors, they would both be 11 or more. That means that the product is 121 or more. So that means we're not going to find any more. So 89 is also a prime number. In this list, 37 and 89 were prime numbers. One more thing. After a while, we will have an instinct about the numbers between 1 and 100, whether they are primes or not. For example, the divisibility by 3 is very easy. The divisibility by 5 is very recognizable. So beware of 91. 91 is tricky because it looks like a prime, but it isn't. It's not divisible by the usual suspects, right? It's not divisible by 2 or 3, because 9 plus 1 is 10, or 5, but it's divisible by 7. So 91 divided by 7 is 13. So that means that we have 4 divisors. Beware of 91. 91 is the trickiest number between 1 and 100. All the other numbers are sort of intuitive with respect to whether it's a prime number or not. Thank you for watching.